Well, I'd like to get into the depiction of a histogram now. A histogram depicts continuous data. And as I may have alluded to in Chapter 1, sometimes we just sort of pretend that data is continuous. You could argue that it should be categorized as discrete, but we'll just sort of say it's continuous. Now, to construct a histogram, you'll first list the numbered scores on the x-axis, and they'll be ascending, lowest to highest. And of course, the frequency is on the y-axis. That's pretty easy to imagine. You can envision it pretty easily. You'll notice something about the way it's depicted. The number falls right in the middle of the column, and it extends to the upper and lower real limit. So let's say a score of 3 extends to 2.5 and 3.5. 2.5 on the left, 3.5 on the right. Conversely, a score of 4 has a lower real limit of 3.5 and an upper real limit of 4.5. The upper real limit of 5 is 5.5, and its lower real limit is 4.5, etc. It's fairly easy to depict, and I'm not real insistent on graphing in a way that is, how to put it, artistically sound. Many of my graphs tend to be sort of crude looking when I draw them in class, but they tend to depict the point. But you can easily see what's going on here is that I've got 1 1, 2 2s, 4 3s, 3 4s, and 2 5s. And from the graph alone, I could know how many scores were depicted here. And let's count them. 1 1, 2 2s, 4 3s, 3 4s, and 2 5s. If I add all those up, that's 12. 12 scores that were comprised totally. And I might, just by looking at this, and we'll talk about skews later here in a couple of slides, this with the numbers stacked up on the right are negatively skewed. The numbers are slightly higher towards the high scores. So if this were a customer satisfaction survey, I might say, well, gosh, I'm pretty proud that, gee whiz, of the 12 survey respondents, 5 were either satisfied or very satisfied with a 4 or a 5. And if you take into account neutral, 9 of the 12 respondents were at least sort of neutrally satisfied, if you will. But it's fairly easy to depict, and the key thing to keep in mind is that the bars should touch, the columns should touch. When we're depicting continuous data, it continues through each upper and lower real limit, and we faithfully depict that by having them touch. I almost wish there weren't those faint spots between the columns. I think it's actually better to represent a histogram without those faint spots. When we draw them graphically, they're supposed to touch. So please bear that in mind. But nonetheless, we're taking this as continuous data. It's often the case that someone looks at quiz data or customer survey satisfaction data and says, well, gosh, shouldn't that be considered discrete? And maybe so, but we just sort of hold our nose and call it continuous. And I'll be very explicit on quizzes or tests. I'm not going to throw any curveballs there. But if this were described as continuous, it's fairly easy to depict. And the thing to keep in mind on a histogram, again, is the number goes in the middle. The column extends to the upper and lower real limit so that the number is in fact straddling those two and underneath it. And the columns should touch. Now, there's something else that depicts, here's another sort of histogram. This is a sort of a differently rendered, I guess you could say, histogram in which the frequency label on the x-axis is omitted, and it appears as though you've just got boxes drawn there, and that's fine. This is another, I guess you could say, iteration of a sort of histogram. It's sort of a different artistic sensibility, if you will. Now, you'll see here that there were one person got a 1, 3 people got a 2, 3 people got a 3, etc. We might pretend this is a quiz. And at the very least, I could ascertain how many people filled out this survey or took this quiz. My gosh, it looks like 1 plus 3 plus 3 is 7, 11, 14. Am I getting that right? So, 14 people took this quiz or answered this survey, etc. And I can immediately tell that by the depiction of the graph. And you could also tell that It extends to each upper and lower real limit, and the columns touch. Now, in this case, the columns have been sort of divided into what I crudely call boxes, but nonetheless, it's the same principle. There's something that's seldom used, and I don't dwell on it too much, as a frequency polygon. A frequency polygon also depicts continuous data, and the number has a dot directly over it. So the upper and real limit, lower real limits here are not faithfully depicted. We merely draw a dot directly over the number. Okay, well, fair enough. And you can see that the dots are connected by straight lines, which tells a story here. And a story here is that, my gosh, more people answered 3 or got 3 correct on this quiz or test than any other number, followed by scores of 2, 4, and 5. Only one person answered 1 and one person answered 6. Another thing that makes this a polygon is the polygon itself, in order to be a whole, WHOLE, should extend down to the number below and the number above. So there is no 0, but we extend down to 0 zeros, if you will, and also 0 sevens in order to make that work. Now, you could superimpose or draw a frequency polygon directly on top of a histogram pretty easily. You can see I could easily draw the red dots directly on top of each of these columns and have it extend down to 6 and extend down to 0. Now, to be honest with you, I seldom dwell on the frequency polygon, because although every textbook features it prominently as depicting continuous data, and it's a legitimate depiction, it's amazing. I don't know that I've ever seen it anywhere in a research article or anything else. Generally, histograms are preferred.